This video will show you how to use the CALC option. Specifically, the second option in the Calculate menu is 0. Once you have inputted the function into the calculator, the 0 option allows you to find all the zeros for the function. Remember that the zeros or roots occur when the function is equal to 0, and this happens where the function intersects the x-axis. In example 1, we would like to find the zeros of the quadratic function y equals negative 3x squared plus 7x plus 9. So let's input this function. Y is equal to, then negative 3x squared plus 7x plus 9. And let's graph this. So here's our quadratic function, and you can see that the function goes a little bit above up here, but we don't really need to see that. So what we need to find are the intersection points here and here. Okay, so we'll go to the second function in CALC, and this time we want to use the 0 option. So number 2. Now there are a few things which are happening on the screen right now. First, it displays the equation. Then it says left bound, and then it gives you the coordinates of where the cursor is at. So what left bound means is that we need to place the cursor to the left of that intersection point. So anywhere to the left of that intersection point we want to place the cursor. So that's very important. So if I move the cursor down the function, okay, let me move it a little bit further down, you can see that the intersection point occurs right here, and this cursor is a little bit to the left of that intersection value. So that is fine, and we can move it a little bit closer if we want, as long as it's to the left. Now, we select Enter, and notice that it changed to say right bound. So what that means is that we need to move the cursor to the right of the intersection point. So anywhere this way, we need to move the cursor. So as we move up, if this is the intersection point there, you can see that the cursor is a little bit to the right of that intersection point, so we're okay. Notice that it put a little arrow here when we selected the left bound. So now we're ready to select Enter, and now it says Guess. Now you don't need to put in a value for the guess, you just need to select Enter. And also notice that it put another arrow right here. So between these two arrows is the intersection point. Alright, so we select Enter, and there we have it. It says that the 0 is at negative 0.922, and you can see that's where y is equal to 0. So remember that where the function crosses the x-axis, the value of y is 0. Alright? Now, let's go to the second 0, which is right here. So we will go second function, and then CALC, and then select number 2. So now we need to move the cursor close to the intersection point. There it comes. Okay, once again it says left bound. So here is the intersection point right there. So we need to keep the cursor to the left of that intersection point. Alright, so right here is fine. So we select Enter. There's a little arrow that it put down. And now it says right bound, so we need to move to the right of that intersection point, and that occurs below the x-axis here. Okay, so that is the intersection point right there, and the cursor is to the right of the intersection point. Now, what the calculator is actually looking for is looking for a change in sign. So up here, the sign was positive because it was a positive y value, and the sign down here is negative. It's a negative value for y. Okay? That's kind of what it means by left bound and right bound. So you have to have some kind of a sign change. So now if we select enter, it says guess, and then we can select enter again. So the other 0 is at 3.255, and there it has y is equal to 0, and that's what we want. Okay? So both of our solutions to this particular quadratic function is shown to the right. Now let's go ahead and illustrate what happens when we don't have a sign change. So let's go back to CALC, and we want to find the 0. Now let's move the cursor right there, or the left bound, that's fine, and we'll select enter. Now if we move it a little bit closer to the intersection point, now we haven't gone below the x-axis, so the selection here and here are still for positive values of y. So if I select enter for the right bound, then we don't need to put in guess, we select enter. It says no sign change. So that's what I was talking about. The calculator needs to see a sign change, and if you do not put in the correct left and right bound, then you will get this error. So we can just quit out of it by selecting enter, and then of course we would start over, second calc, and then go to number 2, 0. Alright, so let's go to example number 2. And in this example we would like to find the roots of the cubic function y equals 2x cubed minus x squared minus 15x plus 2. Recall this was the function we used in example 1 of the trace key video. In the trace key video we only estimated the roots, and this time we're going to find a more accurate value for the roots. Alright, so let's get out of this screen, second function, and then we will quit, and then we will go to the y equals and clear this out, and we can go ahead and input this function. Y is equal to 2x cubed minus x squared minus 15x plus 2. And we will graph it. Here's the cubic function, and again we don't need to see the upper part of this function or the lower part. We're just interested in the intersection points. Each one of these are the zeros. So let's first find the 0, let's say right here. Now go to second function and calc, and select number 2, and there's the cursor, so let's move it to the left bound. Remember it says left bound. Oops, so I went one too far. So there's the left bound. The cursor is to the left of that intersection point. So we'll select enter, and then you can see the little arrow it puts down, and then we will move a little bit to the right, and there it is. There's a sign change, so we can select enter, and then for guess we just select enter, and there we have it. The 0 is 2.937, and you can see that's for y being equal to 0. Alright? And recall from the trace key video that the estimated root is shown to the right. Alright, so let's find this root right here, or this 0 right here, and we go second calc, and we want 0, number 2. So let's move it over there, And again, we want the left bound. So where do you think the left bound is going to be? Is it going to be right here or here? Well, the left bound is actually going to be, remember, to the left of the intersection point, so it's right there. So we select enter, and then we move it to the right, and it's now below the x-axis, so that is the right bound. It's to the right of the intersection point, so we'll select enter, and select enter for the guess. And here's our other root. It occurs where x is equal to 0.132, and there it's showing y is equal to 0. Recall for the trace key video that the estimated root is being shown to the right. Alright, now let's finally get our last root, or our last 0. So we go second function calc, and then number 2 for 0, and let's move the cursor over. So left bound, we're going to move to the left of the intersection point. So right there, select enter, then move to the right, and that's fine. We could also go down one. It's still above the x-axis, so we'll select enter, and then guess, we select enter. Okay, so the 0 here is at negative 2.57, and you can see the value of y being equal to 0. There are times that this value of y will be written in scientific notation. So it might say y is equal to 2.35 e to the negative sixth. So anytime you have e to a negative value, that's a very, very small number, which means that it's very close to being 0. Okay, so don't worry if you do see the y value not being equal to 0. If it's a very, very, very small value, then you're okay. Every once in a while the calculator will show a scientific notation value, and that's just because it's not on an exact pixel. Alright? So recall in the trace key video that the estimated root for this particular one right here is shown to the right. This concludes the video for the CALC 0 option.